Hey everyone, my name is Eric Fox, and I'm a staff engineer and tech lead at Mural. I'm going to be doing a re-recording of a talk that I gave a few days ago for the Minnesota Technology Association titled An Unmarketable Truth, AI is Useless Without Us. Just some additional context, this is me and my cats, and this talk was originally intended for high school and college students. So why am I giving this talk? Well, I've been lucky enough to work in and around AI since 2015. I was a senior engineer in the Commercial Innovation Labs at Capital One for about 2 years, where we worked on ML-integrated invest and loan systems. I was also a tech lead in data at Spotify for about 7 years, where my team owned AI features like a natural language search and a generative AI chatbot for navigating Spotify's data catalog. This work has given me a mental model that helps demystify today's AI marketing hype. The marketing around AI is hand-wavy and mysterious, and that's because it's great for drawing investment. This mystery is also scary and demotivating for people who are outside that loop. I'm here to give this talk to let people know that AI is not actually mysterious, and it depends on us much more than we realize. To prove it, I'll explain AI simple enough that a high schooler can understand it. Trigger warning, this talk contains many oversimplifications in order to make the content accessible to non-technical audiences. Chapter 1. Inside an AI model. So, you know what a formula is. For example, if you want to find the circumference of a circle, you take the diameter and you multiply it by pi. In coding, these are just called functions, and they work the exact same way. You have a couple inputs, you do some operation on them using math, and then, on the other side, you get the output you want. An AI model is just a massive group of tiny math functions. We call this a neural network because each function acts like a neuron or a brain cell. They wait to receive a signal, they do some math, and then they pass it on. Here's a textbook model of a neural network. On the left, we have inputs, or observations, and on the right, we have outputs, or predictions. And in the middle, we have these green layers of neurons. We don't actually care what math each neuron does, because this is not important. We only care that when they're done thinking, the output is what we expect. Chapter 2. Let's train an AI model. This is a Galton board. Some of you may have seen it in your statistics class. It's often used to demonstrate simple probability. The way a Galton board works is that when you flip it upside down, all of the marbles go back to the top of the hourglass, and then when you flip it right side up again, they pour out through the spout and down through the layers of pegs until they arrange themselves on the bottom. They always arrange themselves in this nice bell curve because each peg has a roughly 50-50 chance of having a marble go to the left or to the right before it hits another peg. And as the marbles fall down through these different layers of pegs, it gets less and less likely that they will always go to the right or always go towards the left. In most cases, most marbles will fall somewhere in the middle, just like you would get roughly half and half heads and tails if you were to flip a coin X number of times. So, a Galton board works because the 50-50 math at each peg makes the output predictable. In this example, the pegs are like neurons. They're just tiny math functions. All they do is run a 50-50 probability calculation. And the marbles, these are our inputs. The bell curve is that predictable output that we get from our model. So what if we wanted the marbles to fall in a different shape than a bell curve? For example, in this strange sawtooth pattern that I've drawn on this diagram. Well, with the pegs as they are, this would be completely impossible. We would need to train the pegs. What if we had each peg make tiny tweaks to its size, shape, and position until the marbles started to fall into the shape that we wanted? These pegs, which are nice, perfectly sized, evenly spaced right now, they would look nothing like they did before after we're done training. Congratulations, you now know how to train a model. It really is just tons of iteration until we get closer and closer to the behavior that we want. And when we have that behavior, we say that the model is trained. The exact same thing goes on in your brain every day. As you learn new information, The neurons in your head retire old pathways and strengthen new pathways so that that information and those modes of thinking are easier to access the next time they come up in your life. We use neural networks to do predictive calculations for tasks where collecting training data is easier than writing a perfect formula. The network's predictable output in the face of fuzzy and uncertain inputs is why AI is so valuable. For example, with music genre detection, we might have two genres that are very similar, and we might not have a clear definition of what distinguishes between the two. But if we have enough examples of tracks in each genre, we can train a model to notice the distinction and make a pretty good guess as to where any new song should fall. Neural networks are also used to recommend content. For example, on YouTube and TikTok, anytime you interact with content, whether it be watching it, subscribing to a channel, or liking something, that becomes an input into the model, and then the model outputs recommendations to be added to your feed the next time you refresh. Neural networks are also great for noting subtle visual signals in things like medical imaging. For example, there are models being trained and used in radiography to notice very subtle signals of cancers or irregularities that the human eye wouldn't be able to notice. But there are limitations. Unfortunately, you can't train a model for every possible input. Even the biggest, most expensive models can act up when they see something they weren't trained for. Hypothetically, could we put these into our trained Galton board and expect the same output that we've trained for? Definitely no. These cubes wouldn't act anything like the nice spherical marbles that we've been using throughout our training. And now you know what breaking your algorithm actually means. When you listen to something that is very, very dissimilar from your existing behavior, you have now introduced an input that the model likely didn't have any representation for in its training, and the outputs for your future recommendations might start to get a little wonky. Chapter 3. AI chat is kinda dumb. All LLMs, or large language models, are just text-based neural networks. You input text, they do some text math, and yes, it really is math, and then they output text. That's it. They have no memory. They don't even remember your last message. You might say, well, my ChatGPT seems to remember everything I say, and it actually doesn't. You can see here this very confused Reddit user is realizing for the first time, wait, ChatGPT has to reread the entire chat history every single time? Yeah, that's exactly what it does. In order to get each new message that it sends to you, it takes the entire chat history, your most recent message, and treats that as a total input to generate the next output, which is what gets sent back to you. LLMs, like ChatGPT, are just big math functions. They turn inputs into outputs. That's not thinking. But in a lot of cases, it's close enough to be kind of useful. LLMs are great for writing an email, summarizing a textbook chapter, or explaining something like a math formula. But these are all one prompt, one response situations. We want more. In fact, we want AI to be able to do real work. Chapter 4, Agents are even dumber. When an LLM can act on its own, it becomes something called an agent. Almost every AI you interact with today has agentic capabilities. Agents are just LLMs in a behavior loop. They reason, they act, they observe, and then they repeat. This lets them do so many things, really badly. If you did a Google search or looked on Reddit for people talking about AI agents, you'd probably see a lot of the same pattern. Getting stuck in loops, hallucinating, failing, getting stuck on repeat. And there's a really good reason for this behavior. Let's think back on our AI Galton board. What would it look like with an agent loop? What if it could recycle its output back into itself? Well, it would look like this. All AI models have an upper limit on input size. You can only feed in so many marbles before the model becomes useless. This limit is called a context window. The closer you get to this limit, the dumber your model becomes. And there are a variety of good reasons for this. One of those reasons is that as the input gets bigger and bigger, it gets harder for the model to find the parts of the input that are relevant to generating the right output. Another reason is that with sufficiently large input sizes, there just aren't real-world data of that size that we can use for training. This is why ChatGPT starts hallucinating and forgetting after just a few hours of the same conversation. You run out of context window. So let's remember again the fact that every time ChatGPT generates new output, it has to take all of the previous thread as an input. In the case of agents, this context window fills up even without your involvement because of this. Even if you're not talking to the LLM, it's talking to itself. An agent has to read its own internal monologue, top to bottom, every single loop cycle. And each time it does something, like talk to itself or search the web, that internal monologue gets longer and longer. And so we end up here. Chapter 5, the context problem. Why can't agents just ignore or forget the stuff that isn't important anymore as their inputs get bigger and bigger? Well, they would if they could, but they can't. The important stuff is easy for a human to see, but impossible to distinguish for an AI. This is called the context problem, and it's been around in different forms since as early as the 1970s. We don't know how to get AI to figure out what's really important because that involves thinking, and AI does not think. LLMs can output responses that look like thinking, but that's just a reflection of the data it was trained on. If actual thinking needs to happen, and it usually does, then it's up to us as humans to help bridge this gap. Chapter 6, Enter Context Engineering. Context engineering is the process of managing and assembling all of the inputs for an AI model in order to better guide its behavior. It's a new buzzword, and it's been in all of the recent AI white papers. It might sound technical, but as humans, we actually do a lot of context engineering completely naturally every single day. For example, let's say you're in a long lecture and you know you won't remember everything the teacher says, but some of it will be on the test. What do? Easy. You take notes. Structured note-taking is the technique of prompting an AI to save important pieces of information for later use, for example, in a text document. And you can do this right now. Here I am in ChatGPT saying, I just learned about structured note-taking as a context management strategy. Can you summarize it and put it in a document that I can reference later? It creates this document, I review it to make sure it captures what I want, and then I download it so that I can use it later. Later on, if I start a new ChatGPT thread, and it involves context engineering or structured note-taking, I can simply upload this file and ask it to read the file rather than describe the context again or prompt it to do the research to get back to the same level of understanding. Here's another example. Let's say you need to solve a quadratic equation for a homework problem, but you've forgotten the exact formula. What do? Well, you look it up. Retrieval-augmented generation is the technique of prompting AI to reference a trusted external source in order to retrieve information rather than generate an answer itself. Here I am in ChatGPT asking, who is the current Prime Minister of Japan? Look it up on Wikipedia. I'm pretty sure the election was recent. And it responds, the current Prime Minister of Japan is Sanae Takaichi, who took office on the 21st of October 2025. And as you can see, it sourced this answer by looking up on Wikipedia. This is important because every AI model has a knowledge cutoff date, indicating that it wasn't trained on any data from after that point in time. Unless prompted to look externally, an AI model might not even realize it has no way of knowing the right answer to a given question. In a final example, let's say you want your friend to help you make flashcards to study French vocabulary, but they've never seen a flashcard before. What do? Answer. You show them a flashcard. Few-shot prompting is the strategy of including relevant examples in an AI prompt for the model to use as a reference. Here I am in ChatGPT again, and I say, write an educational poem about a chlorophyll that follows this roses are red template. Roses are red, violets are blue, mitochondria work hard so you don't have to. And it responds, roses are red, violets are blue, chlorophyll drinks sunlight to make food for you. And as you can see, I didn't have to explain every detail. I didn't have to explain to it how to start the poem, what meter to use, when to rhyme. It was able to infer all of that because I gave it an example that captured all of those details. These are just 3 techniques that have emerged from an ever-growing field of research into context engineering. In a long-running agent loop, the use of even one technique can dramatically improve context efficiency. And with less context spent per cycle, agents can take on much more complex tasks. The key takeaway, though, is that human judgment is necessary for leveraging every one of these techniques effectively. AI cannot assess when or how to apply them. A human has to judge if the structured notes capture the key information. A human has to judge which external source can be trusted to provide the right answers for a given question. A human has to judge which examples capture the essence of the task. And this all comes naturally to us as humans. This comes naturally to you. Yes, you. Chapter 7. So what now? You might be thinking, is this supposed to motivate me? Or what do I do with this information? Well, the truth is that all roles are changing in one specific way. The nature of work will become more human. Speaking personally, the boring, repetitive parts of my job now take less time than ever, and the creative, interesting parts of my job have become most of what I do. Whether it's work or school, a little AI fluency can free you up to keep your focus on what's fun and engaging. Every day, I'm a little less convinced that AI is the scary kind of change, but either way, it's a change that all of you can get ahead of. Chapter 8. Here's what I would do. Being a student is the perfect time to get ahead of this shift. I'm going to show you some facts based on research that I think support this claim. Fact number 1, it seems that using AI is how you become AI fluent. This is based on a workplace study done by the Federal Reserve Bank of St. Louis. What they found was that for workers, time spent using AI correlated linearly with AI skill or how much time you saved because of AI. This chart shows that for employees who used AI only one day in the previous work week, only 11.5% of them could say that it saved them 4 or more hours. In contrast, for employees who used AI every single day in the previous work week, more than a third of them, 33.5%, said that they were saved 4 or more hours because of AI. Fact number 2, the less you know, the more AI helps. And this comes from 2 different studies, one done by the National Bureau of Economic Research and another done by UC Berkeley. What the NBER found was that gains from AI correlated linearly with lack of experience and lack of skill. They did this workplace study in a call center, and what they found was that employees who previously ranked the lowest in productivity saw the highest gains in their productivity after the introduction of AI into their workflow. And similarly, they found that for employees with the least tenure, less than a month, those employees also saw the highest relative gain in productivity after the introduction of AI. And it's not just in a workplace setting. AI can be used as an effective tutor as well. The researchers at UC Berkeley found that for many subjects, tutoring from an LLM is just as good as a human tutor, especially for subjects like math or statistics. What they found was that though there was a statistically insignificant difference between the performance between a human tutor and ChatGPT, both were statistically significantly better than a control of no tutoring at all. As a completely self-taught software engineer myself, my biggest weakness was unguided learning. AI could have turned my 2-year career change into maybe a year or less of AI-assisted learning. Fact number 3, for students, AI is usually cheap or free, and the source is myself, who has to pay out of pocket. You can test this right now. I encourage any of you to go home today and ask ChatGPT how to become AI fluent as a broke student. It will give you a bunch of resources, maybe even a full plan on how to do exactly that. Fact number 4, most students sabotage themselves by using AI to cheat instead of learn, and this was found by an MIT study titled Your Brain on ChatGPT. The experiment took place over 4 months across 4 sessions, and in each session, participants were asked to write an essay. They were split into 3 groups: an LLM group, which was told to use an LLM like ChatGPT to help them write their essay, a search engine group, which was told to use a search engine like Google to help them, and a brain-only group, which wasn't allowed to use any external tools. Across all 4 sessions, participants would wear an EEG hood to record their brain activity, and their submitted essays would be scored based on academic and linguistic criteria. Though the LLM group saw less brain activity, their graded performance was pretty good for the first 3 sessions. However, the real experiment took place in the final session, where the researchers completely flipped the participant groups. For the final essay, the LLM group wasn't allowed to use any tools at all, and the brain-only group was told to use an LLM for the first time. And what they found was that LLM-only participants showed weaker neural engagement and performed worse than their brain-only counterparts on both linguistic and scoring measures. And that even when given access to an LLM, brain-only participants did not show the neural underengagement seen in participants who would use an LLM from the start. The researchers postulate that during learning, using AI might actually prevent the formation of key brain networks, but that after learning is finished, AI can actually enhance efficiency without undermining those networks. The researchers also suggest investigating a hybrid strategy for AI usage, where AI handles routine tasks while the core cognitive processes like idea generation and critical revision remain user-driven. The key takeaway here is that being AI fluent is not the same thing as being AI pilled. Your skill set should balance AI with learned knowledge and practice problem solving. So how should you avoid becoming accidentally over-reliant on AI? Well, I like to think of AI fluency like bicycle gears, and I like to think of AI over-reliance like training wheels. Gears on a bike help you go faster with less effort, but you need to already know how to balance on 2 wheels. If you don't know how to balance and you lose your training wheels, you fall over. You effectively cannot ride a bike. So always ask yourself, if I had enough time, could I accomplish this same thing without access to AI? And if the answer is yes, you're probably in a good place. But if the answer is no, you might want to go right back to your AI tools and say, hey, I think there's a gap in my knowledge. Could you help me come up with a lesson plan or quiz me on my understanding to make sure that I have this kind of knowledge? Also, it's just not that hard to tell in an interview setting when someone uses AI as a crutch rather than a tool. My source here is that I've led hundreds of interviews in my career. I was one of the co-authors in the work group that wrote the Spotify Global Engineering interview, and I'm currently helping revamp our interview at Mural to factor in AI fluency. So, finally, I won't tell you to use AI for all of the things you're probably already tired of hearing. This isn't a lecture, and I'm not your advisor. These ideas will come to you naturally as you get more fluent and build your intuition for when and where AI is useful for you. All I want is for you to get started. And please, try and have some fun with it. The end. Thank you for listening. Special thanks to Katie Oppheim for organizing this talk and being a great colleague. And also thank you to the Minnesota Technology Association for hosting me as a speaking guest.